Hello, everybody. Okay, I have no sense of feedback, so if you guys can't hear me or something, write it in the chat. But hey, everybody, my name is Camila Ramos. I am DevRel at Edge & Node, supporting the Graph protocol, and today we're going to be doing a workshop on building subgraphs on Ethereum and generally how to build decentralized APIs on any L1. Cool. So I'm going to go ahead and just jump right into it. Before I start presenting, just a quick intro about me. I come from the traditional Web 2 world. I was doing engineering at PayPal before joining Edge & Node. I've been doing education and teaching people how to code. Before I was doing DevRel for like 5 or 6 years, I taught kids how to code. So I've always loved to teach. This has always been my passion. So then when I found out that there's a career called DevRel where you basically just get to teach people how to use your products, you get to build relationships with them and just generally engage the developer community, it was a really great fit for me because now I get to come and teach people like you guys how to build cool stuff. Okay, now I'm going to share my screen. Hey, Christopher, can you, is everyone good? Can you guys hear me and see me and everything's okay? I look really blown up in my display. Am I super zoomed in for everyone else too? Okay, I'm not getting any feedback on that, but I think it's fine. I'm actually going to just move over then to some better lighting. There we go. Perfect. Okay, cool. Perfect. So now in this, okay, there we go. So I moved it back a little. Cool. So Edge & Node is a core developer of the Graph protocol. So that's where I work. And there are many different core developers that work on the protocol. And one of them is Edge & Node, and that's where I do DevRel at. And today we're going to talk about what the Graph protocol is and how you can use it to build decentralized APIs on top of Ethereum or any L1. So I'm going to go ahead and start sharing my screen. Share screen. Okay. Oh no, it said it lost permission to capture my screen. 1 second. System preferences. Google Chrome. 1 second. Let me see. Cool. 1 second. It just is asking me to update my settings to be able to share my screen. So let me work on that real quick. Okay. Slides. Computer. Okay, it's loading. Okay, cool. So can you guys see these slides now? It looks like you can. If you cannot see the slides, let me know in the chat, or I'm going to assume that you can't see these because I can see them now. Okay, cool. So again, my name is Camila, and we're going to get started. So if you are familiar with how GraphQL is used in Web 2, that's going to be really helpful. And I'm kind of assuming that more people are coming from a Web 2 background than a Web 3 background. So I'm going to draw a lot of comparisons in how GraphQL is used in Web 2 versus how it's used in Web 3. So the Graph protocol is called the Graph, and we make use of the GraphQL query API. So if you've ever used GraphQL and you've used kind of the playground where you can make queries about your data, we do the same exact thing. Instead of reading from a database, we read from a blockchain. So that's exactly what we're going to get into. So in Web 2, you on your client application, you write this API and then you write a query for it. And then your GraphQL server goes and reads some data from a database to retrieve the data that you're interested in. It's data source agnostic, meaning that you're not tied to any one specific type of database with GraphQL. So you can use a SQL database, a NoSQL database. You can use MongoDB. And again, you read from some database, or sometimes you go ahead and call another API to resolve the data that you want to look for. And the way it works is that you have some logic, some functions called resolvers that apply logic to your database to construct the objects in your schema, aka the objects that you're interested in querying for, and then return them. So we're going to get into what that means a little bit more. Now, in Web3 with the Graph protocol, it's chain agnostic, meaning that you're not tied to one chain. You can use this with any of the L1s that we support. And there are some that we don't support, but those are being integrated in the future. And instead of reading from some database, you're reading from a blockchain. And then similarly, resolvers apply logic in the same way to construct and return an object defined in your schema. Now, at the time of making these slides, the Ethereum block count was at 14,525,770. And that's just the number of blocks, right? In a blockchain, transactions are batched together into what are called blocks, and those blocks are connected. So although there's 14 million blocks, there's way more transactions that are stored on the blockchain. And you as a developer might want to query for some data, and it could live anywhere in this blockchain. Now, my little animations are missing because I had to download these files to show them. But it's like a cool animation of showing like that your data could be in any one of these blocks. And you as a developer, because of the nature and the structure of a blockchain, there's no built-in mechanism to identify, query for the data that you're looking for. And that's where the graph comes in. So the graph is an indexing and query protocol used to efficiently read data from the blockchain and expose it using the GraphQL query API. Now, the important thing to note about the graph is that it allows you to efficiently read data from the blockchain. Now, there are other ways that you can read data from the blockchain. If you guys have ever been on Etherscan and you click on read contract, you can see that you can actually query for some items like the token ID or the URI. Those are queries that are easy to make using those public functions or those public methods that are available on a smart contract. But for anything that is more sophisticated or anything where you want to do things like finding relationships between data, full text search on data, things like filtering and mapping, you're not going to be able to do that without something like the graph or without your own indexing service. And we're going to talk about what that looks like in a second. So for those who maybe aren't familiar with GraphQL, this is what a playground looks like. And a playground is kind of your testing ground before you actually use it in your application. So if you look on the left, there's your query. And then on the right is the data that gets returned from this query. So it's just to give you kind of a quick visual if you are not clear on what maybe I've been saying when I say query, you're basically just asking for information. So in this example query, I'm asking about an NFT project that are called ladies. So I want to get the first 5 ladies and I want to query their ID, their token ID, their token URI, the owner, and then that owner's ID. So by owner, I want their ID. And then again, I'm down here, I'm querying for the first 5 users and I want the user's ID and then the ID of the ladies that they own. So that's what we're going to go through building today. So just a quick note on indexing. Indexing refers to the process of turning unordered data into an order that will maximize the efficiency made against that data. So for example, if you are in a library and you're looking for a specific book or a specific type of book, you don't just walk around the whole library looking from book to book for what you want, right? The library has an indexing system. Usually it's the Dewey Decimal System. And if not, at the very least, I mean, all libraries do that. But even if you want to cut that out, they're always categorized by genre. They're usually categorized by, maybe even year. So that's an example of indexing. So instead of making people look haphazardly for something they want, they created an order that will maximize the efficiency of you looking for a book. So that's what the graph does with blockchain data. We organize it into a way that will make it easy to quickly ask questions about your data. And here is what kind of the role that your subgraph or your API plays in your stack. So with the graph, when you build a decentralized API, it's called a subgraph. That's the term that we use. So your subgraph sits between your UI, your client application, and the blockchain or your smart contract. So when you're building out an application, for example, you could build, I just saw a really cool example yesterday of a new project where they're using a subgraph to track like the top 100 songs on a decentralized music streaming platform, just like the Billboard Top 100. So they use a subgraph to query for, songs based on their like how many plays they've had, how many minutes of listening time, or whatever metric that they define. They created a subgraph for this, or an API for this, and then they use that API to hydrate their clients or their UI. So as these metrics change, their UI and the indexing updates, and then brings the newest top 100 and the newest top 10. And before we start getting into building a Web3 API with the graph, I think it's easier to understand some of the pain points if we start by talking about what it would be like without the graph. And this, for me at least, it really helped me understand why the graph even is a thing. So let's say that we wanted to build an API that allows users to search for an NFT with specific traits. So, you see a lot of people using NFTs as their profile pictures on Twitter. But what if you wanted to build an API so someone could find one that kind of looks like them? Maybe they have the same hair color, skin color, or whatever other traits that they desire. So with this specific project, there's these properties that we're going to want to query for and allow a user to find one that they identify with. So if you wanted to do this without the graph, one way that you could do it would be to take each unique token ID that maps to one of these tokens or one of these ladies or women. You would read the metadata for each one. You would aggregate it, so put it all together. And then you would write a program on the client side to filter out based on some properties. So that's one thing you could do. Another way that you could do this is you could run your own server. You could process and store all the transactions made to the blockchain, save it in a database, and then index this database for reasonable query times. And then you could build an API on top of this database like you would in Web 2 and expose this data via an endpoint. Now, both of these aren't great solutions for two reasons. One is that these both take a lot of, especially scenario number 2, engineering resources and in time and actual engineers. So building your own indexing server takes a whole engineering team and it's a multiple week project. And on top of that, it breaks the kind of core tenets of decentralization, because if you're building a decentralized app, but you have a centralized indexing server that could go down, it's going to take down your whole app. Now, with the graph, it allows you to do this in a decentralized manner and in a really reasonable and efficient engineering spend. So we're going to show you now, we're going to build a subgraph in like 17 minutes or something. And obviously, like the more complex that your subgraph gets, the longer it's going to take. But generally, it's really quick to spin up a subgraph for your project. So anyone can develop a subgraph, and there's already hundreds of subgraphs deployed. And the cool thing about subgraphs is that once you deploy them, they become open and accessible APIs that anybody can use. Just like, there's the Twitter API, there's the WhatsApp API just became public. There's a bunch of other APIs out there that we use, the Spotify API. But the thing is, a lot of these companies, sometimes they keep their APIs private for whatever reason. Some companies make them public. But with the graph, all of your subgraphs, once you deploy them, become publicly accessible. Anyone can use these to grab data and to use them in whatever way that they want. So if you can kind of see, there's a lot of cool projects that already use the graph. LivePeer uses the graph. Uniswap uses the graph. Radical, Pool Together. And I'll drop the link later, but if you go to the Subgraph Studio Explorer, you can see and browse all of the different subgraphs out there and just play with them and check them out. So to develop a subgraph, as a developer, there's only a few things you really have to know and define. So the first thing is the data source. So what is the smart contract address or addresses that you're interested in indexing? You define the data that should be indexed. So in our case, it's going to be those traits that we want a user to be able to search by. 3 is the events that you want to listen for in your smart contract. And the reason why you want to do that is because, for example, for our NFT one, if we want to know who the owner of these tokens are too, because if we want to use it as a PFP, we want to know who the owner is so we can maybe have a conversation about swapping or purchasing. But if you make a query and it says, okay, the owner is, this address, 1234, but then the owner sells it tomorrow, you're going to want a way to get the most recent and the freshest data every time. So the way that you do that is by defining certain events that you want to listen for that will then trigger resolvers that will trigger resolvers when those events are emitted. So for us, in this specific example, the events that we want to listen for are the transfer event, because in an ERC 721 contract, the transfer event is emitted when a token is minted, so when it first becomes available for sale, and then when it gets transferred, sold or bought. So those are the two scenarios where the data that we're interested in could change. So those are the two, or the one event and the two scenarios that we're going to want to listen for and say, okay, when this happens, trigger a re-indexing to make sure I have the freshest data. And now the other cool thing that I love about the graph is, as a developer, you only have to work with 3 files. The first file is the manifest, the subgraph.yaml file. And in this manifest, this is kind of like your map for everything. So you're going to define the start block. Now, the start block defines which block you want to start indexing at. So this is an optional parameter. You can leave this empty and it'll just start indexing from the very first block of whatever L1 you're on. But if you're like us, where we're building an NFT API for a very specific collection that came out this year, we know it's not going to be in the first 15 million blocks, probably, right? It's not going to be in the first 10 million blocks, definitely. So in order to kind of save some time on indexing, you can pass in the start block, but again, that's optional. The second thing that we're going to define are the entity names. So the entities are the objects in your schema that you're going to be querying for. So in our case, it's going to be a lady and a user. So those are the two objects that we want to be able to query for information of. And finally, you're going to define your events and your event handlers. So again, the events are the things that you want to listen for. And then the event handlers are the functions or the resolvers that are going to execute when these events are emitted in order to re-index and get you the freshest data. Second file you're going to work with is a schema.graphql file. If you've ever worked with GraphQL, it's exactly the same as in Web 2. The only thing that you'll see different is the @entity directive and the derive from directive. These directives are unique to the Graph protocol, and the derive from directive is what allows us to actually create relationships between objects. And the entity directive is to indicate that it's a top level entity in our schema. So you'll see for Our Lady, the things that we're going to talk about is the ID, the token ID, the token URI, the owner, the name, the facial expression, hair expression, skin color, eye color, and then for user, their ID, which is the wallet address, and then the lady tokens that they hold. And finally, the last file we're going to work with is the assembly script mappings file. So this is your resolvers. These are the functions that you're going to write that actually construct the objects in your schema. So, these are all things that we're interested in, but the computer in your program has no idea how to actually get these. You're just saying, this is what I want to get. And in the mappings, you define, this is how you get it. This is where you go get it. This is how you construct it. So those are the 3 files that we're going to work with. And let's just go through that now. So let me share my screen. Let me see. I think I'm going to have to get on Safari. So it won't let me share my screen. Let me see. Share screen. Let's see. 1 second. I'm going to try to open this in Safari and see if it'll let me share this. I've had this issue on my M1 since I got it, where it no matter what settings I apply, it gives me problems when I try to share my Chrome screen. Let's see. Share screen. Okay, hold 1 second. Sorry, guys. Give me 2 seconds. Let me try to fix this. I'm going to try to rejoin the stream from from Safari. Let me see if that works. Oh. Okay, you can't even use Safari. Okay, found it. Hey, Richard. If I quit this stream and rejoin, will I be able to rejoin? I have to quit because I had to update my system preferences, and in order to apply them, it wants me to rejoin. Okay, I'm gonna quit. Be right back. BRB. Quit. Okay, cool. Sorry about that. Okay, now I'm back. Now this should work. Please work. Yay. Okay. I think you guys can see. Perfect. All right. So now we're going to go through this workshop together, and I'll paste the link in the comments. So for people who want to, oh, yeah. So I'll actually send it to Richard, and I think he's going to send it. So for people who want to follow along, but I'm going to be showing it on my screen. So you should be able to see my screen, but just in case you miss a step or something, I'm going to share that there. So this is on my GitHub, and it's available for anyone to follow. So even if you maybe just want to watch now and then complete it later so that you're able to really pay attention, don't worry about, following along right now because this link is open and you can do it wherever. So the first thing that we're going to do is we're going to go to the graph, and we're going to create a subgraph in their UI under the hosted service. So the graph has a hosted service and the decentralized network. We're going to be using the hosted service today because the decentralized network hasn't reached feature parity with the hosted service yet. So because we're using the specific API that we're going to talk about, which is the IPFS API, we're going to have to use the hosted service. So we're going to go over to our dashboard, add a subgraph. I'm going to call this chain link, and then just add a subtitle. And now you're good. Create subgraph. Cool. So the next thing that we're going to do is we're going to go into, well, first for you, you're going to have to install the graph CLI. I already have that installed. So I'm just going to go ahead and open my terminal. Oops, that's not what I wanted. iTerm. I'm just going to go into the folder that I want to use. Let me make this big screen. And I'm just going to go into my workspace. And let me put this side by side so you guys can follow along. Cool. So the way that we're going to initialize this is by running this command, and we're going to talk through exactly what it does. So we're saying graph init from contract flag, and we're passing in the contract address. So let me show you guys what contract this is so you can get a good sense of where we're going. Etherscan. So this is the Fame Lady Squad NFT collection. That's why in our schema it's called Lady, Fame Lady Squad. And then we're passing in this flag called index events. And what this is going to do is going to make it so that the CLI automatically indexes every event that's emitted in this contract for us. And that way we're going to just get some code out of the box, which is going to help us out. So if we hit enter, here you define the protocol. Right now, this contract is on Ethereum. We're in the hosted service. And for the subgraph name, we're going to use your GitHub handle / the name of the subgraph you gave here in the UI. So I use Chainlink, so that's what I'm going to use here. I'm just going to call this chain link. This is on mainnet. Confirm the contract address. And then this is going to scaffold out an app for us to get started. So here I have all these steps that I just went over, including like how to actually name your subgraph so that you don't get any errors. And the first thing that we're going to do is we're going to cd into the directory I just created. And I'm just going to open this in a browser, in a code editor. So I'm going to move this over here, zoom out of this. Cool. So the first thing that we are going to do is go to our schema. And here we're going to update our schema. So let's just kill all of this. And remember, what we're doing is that we want to define the object and the properties on that object that we want to be able to query for. So the way to start doing that is, well, what I always do is I go to the contract and I read the contract. And I actually want to read the metadata first because I need to know what properties are even available. So I'm going to scroll down here. And by the way, this is what I meant earlier when I said you can make queries against a smart contract, but only really simple queries like this. Who is the owner of, token ID 20? So I do get an address, but if I wanted to know anything more complex than single queries, like what's the base URI, what's the balance of, then I would need something a little bit more advanced. So I'm going to copy this IPFS hash because this is where their metadata is stored. So I'm going to go ipfs.io/ipfs/ and then /20, I'm just going to pick a random token. So here we're able to see the metadata from IPFS through their gateway. So what I always do is I just pop this into a JSON formatter just so it's easier to read. And I'm just going to hit process. So if we open this and just take a look, the metadata is a JSON object, right, as we would expect. And in the object, one of the first properties we see is name. So we can say, okay, we know that we have a name object. We know we have a description property, we have an image property, we have an attributes property where the key is a string called attributes and the value is an array of objects. So if we minimize all these, we can see that this is an array of, 8 objects. And in these objects, we actually see the attributes that we might be looking for. So the key is trait type, the string, and then the value is the actual property of that. And then for the next one in that object, the key is the string value, and then the value is the actual property that we're going to be looking for. So by looking at this, I can say, okay, I have a skin trait, I have a background trait, a face expression, a eyebrows, eyes, body, etc. So this is what informs us and what we're able to actually define on our object. So now that we know what's available, we can go back into our schema and say, okay, this is what I'm interested in. I'm just going to go ahead and copy and paste this over for the sake of time. So what we're defining is we want to know the name, which we saw, the face expression, the hairstyle, skin color, eye color, and then the ID, the token URI, and then the owner. So now we have to define this user because this isn't a primitive type, right? This isn't like a big int or a string. We're making up our own type here. So we have to define what that type actually is. So here we're going to say, okay, type user means this. Cool. So now we're going to save this. Oh, this is something else. We're going to save this and then go back to our terminal. And then in here, we are going to run this command graph code gen. And this command is what's going to generate the types for the contract ABIs, and it's going to like generate a bunch of starter code for us based on our schema. So now if we open back up VS Code, let's minimize this. So now see we have this new folder called generated, and we have this new folder called node modules. So that's what just happened when we ran that command, graph code gen. So the next thing that we're going to do is we're going to go into our subgraph.yaml file and define those things that we talked about earlier. So first thing we're going to do is add a start block. So if you look over here, I show you exactly where to do it. It goes under your ABI here. So start block. I know the start block for this because I was able to look it up on Etherscan. So I know it's 1, 2, 813031. And then for entities, these are not the entities that we defined, right? These are the ones that came with it. These are the ones that we deleted. So our new entities are lady, see, with the entity directive, and user. So we're just going to define that. Lady, user, cool. And then finally, the last thing we're going to update are these events and event handlers. So remember, the events that we're interested in are only the transfer event, because we only care to know the information that we want to index when a token gets minted initially, and then when a token gets transferred. All these other events we don't really care about for this specific use case, but obviously depending on what API you're building and what the uses are, that might be different. So the event that we want to listen to is index, and then the handler or the resolver that's going to execute when this event gets emitted is called handle transfer. And this is the function that we're going to define in a second. So it hasn't been written yet. We just said, hey, we're going to call it handle transfer. So I'm going to save that. And the last thing that we have to do is go into our source folder and go to mappings.ts. So here's where we're going to write our resolvers. So the first thing that we're going to notice are these errors. It's saying you don't have a member approval in your schema. And that's true. The only things in our schema are lady and user. So let's go ahead and import those here. Lady, user. Okay, so now it has that. Now also, we didn't use any of these other events, so let's go ahead and delete them. Cool. And now we're just going to literally delete all of this, because this was some code that came out of the box that we're actually not using. And here I'm going to show you how we're going to find this code. So I'm actually going to paste this too, but then we'll walk through it together. So the code is here. And if we go here, source. So I'm just going to go ahead and copy this all the way down. So remember I said earlier that the reason why we're using the hosted service is because we're using a specific API. So the specific API we're using is this IPFS API. So because we need to read our metadata from the IPFS, right? Because that's where the metadata is stored. It's not on chain, so we need a way to actually construct our object and find out, hey, what is the hair color? What is the eye color? And those values are on IPFS. This is the API that hasn't been built out yet on the decentralized network. So that's why we're using the hosted service. So now let's walk through this. So here I just defined what we're importing, and here on line 10 is where we start. Let me make this a little bigger. So the first thing that I'm defining is the IPFS hash. Now this is the hash that we got from the token in their contract. So that's this hash, the base URI hash. All of the tokens in this collection share this hash, and then the thing that's different is what comes after this slash. So we define, hey, this is the common hash for this contract. Then we define our handle transfer, which is the actual resolver that's going to get executed when a transfer event is emitted. So the first thing we're going to do is we're going to say load some token ID from the event parameters. Then we say if the lady doesn't exist, which she doesn't, because this is how we construct her, we're going to create a new lady. We're going to grab that token ID and make it to string. And here's where we define the token ID and the token URI. And this is just simple stuff that comes from the event itself. So nothing here so far that we've really had to construct. We're just grabbing stuff from the event parameters. Here's where we start actually constructing our object with stuff from IPFS. So we create a variable called metadata, and we call this IPFS.cat method on it. And we pass in the hash that we defined above, plus the token URI, because remember, that's what's unique. So they all share this hash, and then it's slash 20 or slash 30. And we see here that in the token URI, we add that slash here. So then we say, okay, if this metadata comes back, if we're actually able to find something here, let's go ahead and turn this into an object. And we're going to go through all of the values and look for our first value, which is name. So the first thing that we're going to do is we're going to search for a value by its name. And the name is like actually the name property. So it's this property right here. So this is what we're looking for. We're saying literally go grab the key that has the value of name, or sorry, that the key at itself is name. That's what we did there. And then we see that the attributes, remember, are in an array. So we do some work there and we say, hey, this is an array. And now we want to loop through this array and grab the trait types and the trait values. So that's what we're doing here. We say get the value of attributes and then turn it into an array. This is just some assembly script stuff that's like unique to assembly script, but don't worry too much about it. Then all we're doing is looping through the attributes array, and we're doing the same type of retrieval by name. So we're saying get the trait type, and now, which is assigned to this variable. And now we're going to go through and say if the trait name equals any of the things that we're interested in, which is right, hair, skin, eyes, face expression, then I want you to save that. So here we go. So we say let trait value equal item.getValue, because remember the key is actually the word value. So that's what we're doing here. We're saying go to the place where the key is the word value. Now, if this comes back as something, if we're able to find something, turn it into a string. Now, if trait equals hair, then go ahead and save that to the lady. So save lady.hairstyle to equal that value. And the reason why this says hairstyle instead of hair is because in our schema, we said hairstyle. Now, if in our schema, we would have said hair, or if we would have said hat, and here we would have also said hat, because we're constructing our object. We're actually telling our schema and our program how to build out this object. So, but we didn't do that. We said hairstyle. Let me save that. Perfect. And then we just go down the list. If trait equals skin, let's go save skin color. If trait equals eyes, let's save that. And if trait equals face expression, let's save that. Now, the most important thing that you're going to see here is this .save method, and this is what actually saves this data to the graph node. And the graph node is what actually makes your data available to be queried for. So you'll see this is the most important thing here. And we're actually saying, okay, we've constructed our object, and now I want to save it and put it away. So when I'm ready to query for it, it exists. And then we do something similar with user, where it's a lot simpler because the only thing we care about the user are their ID and the ladies that they hold. And we define that here. And that's literally it. So now I'm going to go ahead and save, make sure everything's saved. I'm going to make this back small screen. And the next step that we're going to do is we have to authorize ourselves to deploy this subgraph. So what I'm going to do is open up my terminal again. And I'm going to go here and copy this command. So cool. It's graph auth. And then you're going to pass in your access token, which you're going to get from your UI when you first created your subgraph, which I think I have to make this bigger. There we go. So I'm going to copy this access token and then paste it here. Oops. Okay, cool. So now the deploy key has been set. Now we're going to build this to make sure that this works with no errors. And now if we do have an error, this is where it would tell us when it's compiling. So it says, okay, build completed. Our build was able to be done with no errors. So now finally, we're going to do yarn deploy. And we're going to deploy this subgraph. And by deploying this, it makes it available for anyone. And it's when it's done building, it's going to, there we go. It's going to return this URL for us to make queries again. So in your client application, so in like your front end application, if you wanted to use this API, you could call this API with that endpoint and make queries. So what we can do is we can go check this out in the Graph Explorer and play with it. So let me make this big now. So if we refresh, we see now that it's working, it's syncing. So it's already 86.5% synced, but we actually don't have to wait until it's done. So let's just go ahead and run this example query. Cool. So I ran this, but let's actually like make our own query just to show you. So let's delete this. And let's delete this because I actually don't care much about this. And the cool thing is that if you press option space, it'll bring down all of your options. So let's do name, option space, face expression, hairstyle, skin color, eye color. Cool. So now if I run this, we're able to see that we're able to query for these specific traits. So we see that there's face expressions are poker face. All of these have poker face so far. One of them doesn't have a hairstyle, so this one must be bald. And we can go double check that. So if we actually just copy this and go in here and replace the 20 with the 100, 1000. Let's see here. What is it called here? Yeah, it's called hair. Okay, yeah, she doesn't even have a hair, actually. So that's why it's null. So that makes sense for us. Cool. And yeah, now we've officially built a decentralized API. So let me go back and not share my screen. I think I accidentally put leave studio when I meant stop sharing screen. Oh my God, sorry, I'm trash. Hello. Oh, I'm in the show. Okay, cool. Sorry, I accidentally put leave studio when I meant not stop sharing screen. Okay, cool. So we went ahead and built that. And as you can see, this was done in, this whole presentation was 40 minutes. And I think that took like maybe 12 or 13 minutes. And yeah, now if you guys have any questions, I would be happy to answer them. And again, the link for that workshop is in the chat. I can see it now. And if you go to that workshop at the very top, before you even start, there's a bunch of different resources. So there's a blog post that kind of goes more in depth to how the graph works, if you wanted to check that out. And then you can query the subgraph that we just created on there as well. It's also deployed, but now I've deployed a new one, so you can query that one as well. And then you'll also see a cheat sheet for working with assembly script in your mappings. So there's like a few weird things that you might see when you're doing assembly script if you're coming from JavaScript. So one of them is like you can't use triple equal sign for comparison. You should use double equal sign. It won't even build with triple equal sign. Another weird thing I ran into is you can't use JavaScript array methods, which in hindsight is obvious because it's not JavaScript, but it's so similar to TypeScript that I thought you could. So I just made this cheat sheet for people who maybe get stuck and just want to check it out and see, oh, okay, like I wasn't supposed to do that, and be able to kind of fix that because the error messaging isn't great. Cool. Well, I'm not seeing any questions coming through, which is great. However, if you do have questions like during the hackathon, my Twitter handle is the same as my GitHub handle. So you can always at me. People at me all the time asking for help on their subgraphs, and I'm always more than happy to jump on and help you figure something out. So feel free to reach out to me if you think of any questions as you're building. Cool. All right. Well, I think that is it for me then. Thank you all so much for being here. And yeah, let me know if you guys have any questions in the future. Bye. Thanks, Chainlink. Is there a demo starting from a Web 2 page? What do you mean? Like, is there a demo starting from a Web 2 page? Elizabeth, can you explain a little bit more what you mean, like how to use this in a regular application? If that is your question, yeah, so you use this in the same way you would use a regular GraphQL endpoint. So in your clients, let me just send it to you real quick. Let's see. You would use, let me see. Okay, cool. I just found an example. So this example will walk you through how to use GraphQL with Apollo Client, which is what you would need to use it. And just instead, when you get to the point of passing in your URL for your query, you would just pass in the one that you built. Show how a user would start. How a user would start, like a developer, how a developer would start. Show how a user would start. So like I think you mean on the client application, like how you would actually use this. So I mean, you could build it in a bunch of different ways, but one way could be that, you have like maybe a form and then, you have people type in their hair color or their skin color and, whatever traits that they want to pass in. And then you can pass that to your query and say, return something that matches these arguments, if that's your question. And then I saw another question here. What's my handle? I'm going to type it. Yes, that is my handle. Thank you. So Richard is going to pass it in there. Perfect. That is my Twitter. So you can just DM me. My DMs are open and you can do that. Cool. Okay. Again, the link is in here in this chat. So you can start there and kind of go step by step to build exactly what we just built. And then there's also, I'm going to send the link to the Subgraph Studio Explorer so you can see all the other subgraphs that exist. And, maybe if you don't want to build one, you can literally just query an existing one. So here it is. I'm going to send it to the chat. Perfect. All right. I think that's it. Thank you guys so much and talk to you soon.